So we see Schottky barrier here, formation of junction, Fermi level align at equilibrium, creation of contact potential V naught. So which is nothing but a here this potential V naught, which is nothing but a phi m minus phi s, and potential barrier for electron injection, that is your phi b, that is this barrier to the Fermi energy level phi b. So phi b is nothing but a phi m minus chi. This barrier is called Schottky barrier, whatever we discussed in previous slide. And if it is forward bias, then V naught minus V, that means this barrier is decrease, and electrode drift becomes easier from semiconductor to the metal. Electron move from this side to this side is easy. Here it is behaving like a forward p-n junction diode. In reverse bias, when V is increase, that is V naught plus VR, then barrier is the metal becomes negligible. Here it is behaving like a reverse bias p-n junction diode. Electron flow from metal to a semiconductor is retarded due to barrier phi m minus chi in both cases. So, sorry. So similarly, in case of p-n junction diode, similarly we can find out the uh, width of the depletion layer, potential distribution, electric field distribution. We can determine by the Poisson equation. So here VBI we can define by this way, where Q is the QND for 0 less than X less than W, because it is one-sided. This side is the metal, so that is the depressed layer negligible, tends to 0. Okay. Uh, so this is the Poisson equation. So using Poisson equation, we can determine the electric field. So that is E at the 0, X is equal to 0, minus Q ND W epsilon SI, potential Vx minus Q ND twice epsilon SI W minus X square, and from there we can find out the W is equal to 2 epsilon S Q ND VBI minus VA to the power half. So same way we can determine the all the parameters of the Schottky diode. What is the Schottky diode? That is the metal and n-type semiconductor at the condition of phi m greater than phi s. This is called the Schottky diode. Okay. So Schottky diode advantage is that Schottky barrier diodes are majority carrier device. Metal n semiconductor Schottky. Barrier diodes are majority carrier device because both side is the electron. Number 2, they are extremely fast because majority carrier have very low lifetime. Why low lifetime? Because one side is the empty and another side is fully occupied at the conduction band in n side, this side metal. Then there is a drawn out by the emission. So in this case, the current equation is determined not only the equation of Schottky current equation, there is a harmonic emission also involved. We discuss about that later. So that's they are extremely fast because majority carrier have very low lifetime, very fast in operation, very low cut-in voltage. If current is in this case, what happened? The barrier is lower. So if you apply the very low voltage forward bias, then it can follow the current from either side. So it is very cut-in voltage is very low. High frequency signal detection. High frequency signal detection, that is the application of this diode. So electrical nature of ideal metal semiconductor contact, that is N type and P type, when make a junction with the metal, if phi m greater than phi s, then metal N type is behave as a rectifying, metal P type is behave as a ohmic, metal phi m less than phi s, then metal N type behave as a ohmic, metal and P type behave as a rectifying. All the points are very important. Next we see sorry, non-rectifying, that means ideal non-rectifying characteristics or ohmic characteristics. In this case, what happened? So here V proportional to the I, that means del V by del I is equal to R, which is very low in case of ideal ohmic characteristics. That means this is almost closer to the axis. So it is happened if the metal oxide sorry, as the practically it's happened like this. This is the metal, this is the N plus, this is the N. For example, this is N type semiconductor. So in N side and P plus P metal M. In this case, what happened? You see metal and N plus. So what happened? Then the barrier or the depletion width. This is the M. This is the N plus. So width is very thin, very thin, because before that, whatever the width of the depletion layer, now it is more thin than that. If it is N plus, there is a no barrier actually. So it is then the current flow from the this side to this side very fast, and it is maintain the linearity. Okay, so practically we getting the non-linear or ohmic behavior by this setup, that is metal and n plus, this is n plus and n, that is a another junction. So whatever the current is flow through the metal, so which is behave as a ohmic. So this is basically ideal ohmic behavior or ohmic contact. Okay, up to now, if any queries you can ask. Up to now, if any queries you can ask. Today we discuss about metal semiconductor junction, how to it is formed and how it is work. We discuss about that. If any queries from this topic works. Any queries? किसी को कोई प्रॉब्लम है तो पूछो.
Sir, Scotty barrier
शॉर्ट की बैरियर.
is a short key barrier, sir. Sorry, sir.
Short key barrier. So in case of metal and semiconductor, that is n-type semiconductor and phi m greater than phi s. Okay. So when it is, then according to the rules of the energy band diagram, there is a barrier. Okay.
Yes, sir.
So if there is a barrier at the equilibrium, so when we apply the forward bias, that means there is a negative, there is a positive. So if you apply the negative, that means electrons are inject here. So electron concentration is increase. So due to the forward bias, this barrier is decrease, and electrons are accumulate at the surface of the metal. This is the metal surface. Okay. So here the barrier to the Fermi energy level, this energy difference is called the Schottky barrier. Okay. So in this point, we see that the number of electron or negative charge accumulate at the surface of the metal. So you see, so at the, if there is a charge accumulate at the metal surface, what happened? At the same distance, inner side of the metal, there is a opposite charge, positive charge is appear. Okay, this is the phenomena of the metal surface when the negative charge are accumulate at the metal surface. Okay, so when more electrons are accumulate at the surface, which is metal, then what happened? At the same distance from the metal surface, in metal side means inner side, the opposite polarity charge are accumulate. So due to this positive charge this side and negative charge this side, there is a attractive force, positive and negative. So this force, due to this force, there is a barrier. That barrier is low down. Okay, this force, due to this force, this barrier is low down. One thinks when it apply the forward bias, the barrier is minimized or decreased. Again, due to the higher concentration of electron at the surface of the metal side, there is a image force appear. Image force, why image force? Because both sides the same amount of charge is appear this side electron and this side this side negative charge, this side positive charge, and due to this charge there is a force that is called image force, and this force lower this barrier. So now the barrier is very low for a electron, very low for a electron. So this phenomena, when it is happened, that phenomena is called Schottky effect. Okay.
Yes, sir.
So basic thing is that at the metal surface, if there is a charge, negative charge is accumulate, then what happened? Of inner side of the metal, the positive or opposite polarity is accumulate. Due to this positive and negative charge, there is a force. So during this force, this barrier means there is a potential. This potential is low down. That is denoted by del phi b. So due to that, this low down and there is a forward bias. So due to both case, for the electron, the barrier is very low, and due to this image force, the lowering of barrier, which is called Schottky barrier, is called Schottky effect. You already know about this uh, principle in your HS. If it is metal, there is a charge is appear. There is a opposite charge is create. Due to that, there is a force is appear, that is called image force. Okay. Hello.
Okay, sir. Yes, sir. Yes.
Okay, so this phenomena is happened here. So for that, so this is called Schottky diode, and in case of Schottky diode, it's work as a faster switching because current is flow very fast at the forward bias.